Hi folks, welcome back to Math with Captain Rod. I'm making this video here to demonstrate, to provide an example of how to sketch a basic cosine function, or maybe not quite so basic. This one's got a few things going on. So first of all, let's talk about this 9/5. That means the amplitude of this thing is 9/5, which is just a little short of 2. What is 9/5 as a decimal? Is that 1.8? It's 1 4/5, yeah, 1.8. So if we wanted to, we could write this 1.8 cosine of 3 pi over 2 times x. You'll notice that I've lost the minus sign. The reason I lost the minus sign is the cosine is an even function. We don't need to consider the minus sign because the cosine of minus theta and the cosine of theta are the same. That's a property of all even functions. So now what we're looking at is a basic cosine wave with an amplitude of 1.8. So I'm going to go ahead and put 1.8 up here and minus 1.8 down here. You know, maybe a little further down. We just want this distance and this distance to be as close to the same as we can by eyeball. And now we'll just sketch a basic cosine wave, which would look something like this. These problems usually say to do 2 cycles. I'm going to go ahead and draw another cycle. And now what I'm going to do is just kind of fill in the missing data, which is our scale on this axis. So what I usually do is I look at 1 cycle. So when we look at this graph, we get right to this point right there. I'm going to put a green dot there. From here to here is 1 cycle. And that means that our input angle, which is this, has to equal 2 pi at that location right there. And that allows me to write this quick little algebra equation that 3 pi over 2 times x is equal to 2 pi at that location. And if we solve that for x, we get 4/3. Make sure that that's right. 4 divided by 3, yep. So this x value here is 4/3. Now, cosine wave is symmetric. This is just a sketch. If it doesn't look perfectly symmetric, remember I just freehanded this, but a cosine function or a cosine wave is in fact symmetric. If I cut that in half, we get to that point right here, we get 4/6, which is 2/3. We cut that in half. Technically it's this point. Now the reason it doesn't look quite right is, remember, I freehanded this. This would be half of this again, which is 1/6. Or I'm sorry, 2/6, or 1/3. So we've got a lot of points here. We've got 0, 1.8, 1/3, 0, 2/3 minus 1.8, 4/3 plus 1.8, and so forth. I'm going to consider that a completed sketch. It's not perfect. It's not perfectly drawn symmetrically, but it has all the correct properties to it.